We can start recording now. Okay. Okay, so thanks all for coming. It's great to see so many of you here. I thought we wouldn't get so many folks because of the yellow font situation, but do apologize for that. Next time we're going to try and get some darker fonts so everybody can see it. But it's good to see so many of you here. My name is Danny Tams. I'm a managing architect for Microsoft. We run a team, a worldwide team of folks, and we're the Appliances Center of Excellence. And we drive appliances, set up the ecosystem, do POCs, help in some pre-sale situations, empower partners, work with customers, primarily in the data warehousing space, but also in some of the consolidation areas. So my background has been with SQL Server for many years. I've been working with DBC and specifically this product for easily the past year and a half or 2 years or so, and before that doing consolidation projects. So happy to talk about DBC for the next 48 hours straight. And I can tell you that in this 1 hour session, no matter how deep we go, we're still going to be kind of touching the iceberg here. So happy to take questions either during the presentation, after the presentation, or anytime. Okay, so the objectives here that we want to kind of cover today, by the time you leave, we want to give you an understanding of the benefits of the database private cloud, otherwise known as the DBC reference architecture. Bit of a tongue twister, but from now on we're going to be calling it the DBC RA, reference architecture. Understand the components of the DBC reference architecture. Under the covers, a bit of a deep dive both in the software, how you lay it out, how it's all built, how it's put together, the research, the R&D that we've done, understanding the tools that are available for database consolidation, right? Because after this, you want to get going, you're going to need to size what kind of hardware, what kind of solution you need in order to consolidate hundreds or thousands of database server workloads, right? So we're going to touch on that. So the agenda, touch a little bit. I want to mention the architecture white paper. I've got the link for you. It's about a 60-page document. We want to go through the benefits, some of the savings we've seen customers have, deployments, and also go down the path of talking about the components, how we achieve high availability, failover, and some of the next steps, metering and chargeback and so on and so forth. So we've got quite a number of slides. So we need to kind of keep the pace fairly active. So this presentation is based on this particular white paper up here. Please go to this site, download it. There's lots of great information. The reason that we released this as a reference architecture is obviously many customers around the world are facing this kind of a problem. And where are we right now? We have customers with thousands of database servers around the world. And they're facing how shall I say, spaghetti networks and legacy systems that they need to keep patching and putting up. And this has its own issues as far as scalability, being able to keep your costs in check, both from a management perspective, as well as from a cost consumption as far as power, cost consumption as far as floor space in data centers. Many customers that I talk to around the world, Europe, Asia, especially in the US, are suffering because they've already extended way beyond the floor space that they're typically allowed to in their own data center, or they're in an outsourced data center. And then your costs start to really escalate. Or if you need to purchase a new data center because you're starting to reach that limit, or you have power issues. A lot of the CPU clock rates or the calculations per watt of older hardware is considerably higher than today's CPU consumption per watt is. So therefore, these folks are now looking for solutions. So this reference architecture, described both in the white paper and in this particular session, complies with the private cloud capabilities. So the National Institute of Standards and Technology in the US kind of loosely defined what a private cloud looks like and what are the requirements of a private cloud. Things like, for example, resource pooling, to be able to quarantine and carve out certain amounts of disk space, memory, CPU consumption, to be able to say, I need to use this kind of resource and allocate the workloads from department XYZ on here. Carve out a different set of work, CPU and memory and disk space, and be able to put a different set of workloads on there, and be able to say, I want to do chargeback, be able to do self-service deployments, bringing this closer to the IT user or the business owner. So for example, we're all about empowering the business user or the business owner, right? In many organizations, this is going to be the IT department. When I talk to customers around the world, everything from large banks to manufacturing, they say, a lot of them are very proud. They say, look, we can deploy new infrastructure in a week, right? We've come down from 6 weeks to a week. That's really fast. With the private cloud and the DBCRA that we're talking about, you'll be able to deploy infrastructure in 5 minutes. That's the kind of benefits that we're talking about here. Also, the ability to nominate authorized people within your environment to be able to roll out new infrastructure, to be able to say, I want to scale out. A linear method of scaling out from everything from a half rack up to 10 racks, supporting thousands of database workloads. And control and customization, be able to do chargeback, be able to do metering, figuring out if you want to charge by different departments, different users, different workloads, the cost for CPU usage, the cost for disk space usage, and so on and so forth as you start to use these resources. So what does this Microsoft HP DBC reference architecture provide? We've done all the research, the homework over the past couple of years in order to put together this reference architecture. That means that we've saved our customers potentially millions of dollars. When we talk to customers thinking about this and kicking the tires, they've already spent millions of dollars and many people in order to validate all the different hardware that's out there. Even if you chose hardware for 1 or 2 vendors, there's different SANs, there's different blade enclosures, there's different servers, different network infrastructures. You got to ratify this through different boards and your own committees. Now you have situations where you're 6 to 12 months into a project and you've got not much to show for it other than some Visio diagrams, a few documents, and some PPT. So what this allows you to do is very quickly, seriously, when deployments in weeks, to be able to build an environment that's highly manageable, optimized, highly performant, and be able to deploy that so you can start virtualizing and bringing across all your different database workloads. So it's agile because you can provide SQL on demand. You can roll out SQL Server instances and infrastructure in minutes simply because of the built-in templates. Sure, you can customize these templates, but you can roll out infrastructure. High availability is built in the box already. You don't have to sit there and tweak it. You don't have to test it. It comes shipped to you with this component turned on. So within New Zealand and many other countries, this is known as a process called Factory Express. So when you purchase the DBC reference architecture, sure, you can buy the individual servers, and we provide you the recipe in this white paper, and you can build it yourself. It will come in, a couple of hundred little boxes, and it'll probably take a couple of months to build this thing unless you really know what you're doing. Or you can go HP and say, well, we'll purchase the the Factory Express option, and the whole environment will come pre-configured, pre-built to your door. And there's going to be an engineer that basically configures it and sets it up for your network, right? When I say available in weeks, I really mean, that's exactly what I mean. I'm not saying weeks just as a marketing thing, and by the time it's built, it takes a couple of months. No, seriously. So how did we get to reference architectures? I want to kind of backtrack a little bit in history. Within Microsoft in the data space, there's kind of three different pillars. There's the box product, SQL Server as we know and love it today. You buy it in a box, you install it on a CD. The other one is the cloud, the Azure, the public cloud. And of course, the last one is the appliances and reference architectures. So my team drives the appliances kind of workloads on a worldwide basis. And we also work on reference architectures. So in this configuration, using the reference architecture will also give you a little bit of extra leeway rather than being an appliance in, if you need to, making some choices as far as different software or different hardware that you want to run it with, or make some tweaks. Being an appliance effectively means that the appliance ships as a one complete unit. You can't make any changes to it. But with the reference architecture, we give you the recipe. So you can build it. If you need to make some tweaks to it, you're doing this, of course, at your own expense, right? The reference architecture that we provide is something that Microsoft and HP have spent many, many years in order to test and validate. So we know how it's going to perform. We even tell you how it's going to perform before you purchase it, which is unlike other products, right? As far as IOPS and performance is concerned and various metrics like that. So I don't know, some of you may have heard, obviously, that HP has a number of different offerings in the private cloud space. And I usually get this question, that's why I included this slide as a very high level. We've got Virtual System 1, Virtual System 2, and Virtual System 3. So, and we also have the DBC reference architecture. What's the difference? Why would I buy one versus another, and so on and so forth? So the Virtual System 1, 2, and 3 are excellent products from HP if you want to do normal consolidation or virtualization of generic infrastructure. Say, your normal SharePoint servers or your IIS boxes or your internal applications, et cetera, et cetera. And you'll notice that they are actually fairly CPU heavy, right? So the amount of disk space is actually quite low in proportion to what you'd have in it for a database workload. Because what do you need for a database workload? Well, you need lots of memory. You need lots and lots of disk I/O that is sustained I/O, not peak, so that you drive it and you fill up the cache and then your I/O, your IOPS kind of drops through the floor. It needs to be sustained. So this solution provides repeatable, sustainable 60,000 IOPS, 24 hours a day, 7 days a week. This is not peak, so these figures you can even test them yourself, right? We provide the mechanisms to be able to do that. There's free tools on the internet to be able to do that. We also provide a rating system that kind of gives you an idea. Think of it as horsepower, so you can size how many racks, whether it's a half rack, a full rack, 2 racks, you'd need for a certain type of workload. If you're trying to consolidate several hundred servers of different types, single processor, 2 processor, 4 processor, different workloads. You have some servers that are operating at 5% CPU utilization and other servers operating at 80% CPU utilization. If you've done a large consolidation project, you'll know what kind of a nightmare it is to even just coalescing this information and getting accurate information. So there's tools that we provide in order to go through across your entire network and capture all of this information. And it will go through and provide a sizing guide as far as DBC is concerned. So the reference architecture benefits here, implementing in weeks versus months, or potentially up to anywhere up to a year, seriously. Provision databases in in minutes versus days versus weeks, and large cost savings. All this built in with the scalability so that you can go from a half rack linearly and scale out to 10 racks, which is effectively a pod. Be able to roll this into a data center and mop up effectively all the database servers and instances that were out there, kind of lost in time. One of the kind of tips and tricks I want to leave you with, normally when you do a consolidation project, what we find is that seriously, you can turn off, just simply turn off 10% of the workloads. Why? Because there have been workloads lost in time. You know, there were some projects, some guy bought a server in some department because they needed to do something very important at the time. That was 5 years ago. The guys left the company, you know, moved on, got a different job. The server's just sitting there gathering dust, you know, either unmanaged in a cupboard or under someone's desk. There's still a power bill. Someone still has to replace it apart if something breaks or something like that. There's still cooling that you require. So with this, you can mop up all of this infrastructure. What DBC is not for, right? It's not for taking your largest database, my data warehouse, it might be, you know, 10, 20 terabytes inside and say, I want to put it on this. This is effectively to start mopping up as a cost reduction. People typically, with some exception, typically do consolidation as a cost reduction method. So you want to take, it's not for consolidating your huge multi-terabyte databases or data warehouses. This is effectively for picking up your databases, anything up to maximum of a terabyte. Typically, we recommend 500 gigabytes, 400 gigabytes and below, and taking all this infrastructure and putting it into one location that's managed, scalable, secure, and essentially a mechanism that's scalable so you can do the capacity planning that you need over time. Elastic, you can add more resources, chop and change. You can add DR capabilities to it. High availability is built in from the ground up, right? Think of it as building blocks, Lego blocks. If you need an extra Lego block, you don't take a Lego block and stretch it. You just add another Lego block, and you just keep growing out like that. So, all of this with the guaranteed IOPS of 60,000 IOs per second. And we've tested this and show you how to do that. So there's two approaches. Obviously, there's the self-build approach, which we've seen many customers doing that around the world and spending a lot of times. Also, the DBC reference architecture, the buying pre-assembled hardware, pre-installed software. So when it comes from HP using the Factory Express process, you're ready to start consolidating. I say to customers, in order to do a consolidation project, you can deploy a DBC in weeks, but to consolidate, you're looking at a 1 to 2 year project in most cases, because this is not a situation of you turn this thing on and you start bringing all the workloads in. You need UAT, you need testing, you need to go through the appropriate change control processes within your organization. I mean, that doesn't happen overnight. And if we're talking about hundreds of servers and infrastructure, there's probably management to convince as well. So that's why these are long-term kind of projects. If you're a vendor or a consulting practice or a consulting company, I mean, there's opportunity right here for you to offer this to your customers and effectively build a business around this. So, main message here is deploy with confidence. All the research and the hard yards have already been done by Microsoft and HP in putting together the best of breed for the cost, as far as providing a solution to be able to do consolidation for databases, and specifically for database workloads. You'll see that this is very heavy as far as disk I/O and memory, which is the two things that you need. In the past, we used to really recommend to customers not to consolidate SQL Server, not to virtualize SQL Server. Things have changed. right? With this infrastructure tested, with now you have the appropriate IOPS to be able to sustain a random, truly random workload. So when I say 60,000 IOPS, this is not sequential. Okay, if you start to have even two competing workloads that are both sequential I/O, well, you start putting them together, you get random I/O. Especially when you get to 10, 20, 30, 40 different workloads, it is 100% random I/O. So this is tuned to a ratio of 60-40, 60% read, 40% write I/O, and being able to sustain 60,000 I/Os per second. We give you the recipe to be able to build this. The white paper goes through into detail. The rest of the presentation, we're going to jump into the reference architecture details and specifics, and we'll show you kind of how it's wired, how it's put together, why it's put together, and so on and so forth. So we did to figure out some numbers, we did some consolidation at Microsoft. I think we consolidated about 11,000 servers over a period, saving us umpteen millions of dollars. And we saw a lot of this was energy savings, cooling, to cool a data center down. Effectively, you're starting to take some of the older generations, say the old DL 360s, DL 580 kind of servers that we're not talking about generation 8 servers or generation 7 servers. We're talking about generation 4, generation 5, right? The old stuff that's been sitting in a corner now for the past 3, 4, 5 years. The watts consumed per clock cycle effectively on those older systems is much higher, much less efficient. So you can almost do a translation of physical CPU sockets to cores in being able to figure out one-to-one. But that's not the calculation we use. We use actually a much deeper calculation that actually takes care of and measures IOPS, CPU utilization, memory, and so on and so forth in order to come up with this. So there's also a very significant administration cost reduction to be able to achieve this, right? Effectively, it means that your DBAs, or you as DBAs, will be able to do more things and more valuable things for your organization in the time that you have every day. Instead of coming in at 9 o'clock in the morning or at 8:30 in the morning and starting to spend your first 75% of your day looking at logs and error logs to see what went wrong, or looking at endless reports, you can now manage by exception, right? When you're starting to manage servers and large amounts of infrastructure, you can use the tools like System Center in order to be able to get the best out of your environment. System Center is an integral part of this. If there's a failure in the hardware, you get an alert. If there's a failure in your workloads, you can start getting alerts as well. So you can start consolidating, getting all this information back, and be able to truly manage your workloads. So it's true, you can get large cost savings from this. Let's jump now a little bit, because this is, after all, a deep dive session, and into a little bit more about the hardware, software, what's included under the covers. So the base configuration comes in a half rack. A half rack is effectively a storage block of two P2000s and 6 D2700 arrays. Okay. And it also comes with 4 blades, each blade with 256 gigabytes of memory, total memory, a terabyte of memory. Each blade has 24 CPUs, so it's quite a lot of core capacity. It comes fully racked. It also has the redundant network switches to provide the high availability as far as networking. We're going to talk about it a little later on, but we provide networking at multiple levels. We provide high availability, at multiple levels. High availability at the Active Directory level, high availability at the networking stack level, right down to the hardware and multiple network connections under the covers. This can easily scale to a full configuration, which is effectively doubling this, adding an extra 4 blades, kind of taking you to a total of 8 blades, 192 cores of compute capacity, 2 terabytes of memory, and 57 terabytes of raw capacity. This is when you format this, obviously, because we're using mirroring and RAID 10 under the covers, this will have, get to around about the 24 or 25 terabytes of usable disk space in multiple clustered shared volumes. So how do we scale, right? And we've done this testing so that you don't have to. So you can basically build it out of the box or purchase it out of the box and it works. We can scale from a half rack solution all the way up to 10 racks. And all of this in the one solution uses one instance of System Center in order to manage all of this environment. So think of it as a rating of 200 virtual workloads, database workloads this is, per rack. So 10 racks, we're talking about 2,000 database workloads being able to be managed in a very effective way. Within the infrastructure itself, everything's redundant. I remember POCs and customer workshops, we set up workloads and tell the customer, now go to the server room and yank the power on the switch. Okay, what happened? Go to the server room and we max out the capacity on the blades and say, okay, pull out a blade, see what happens. See all the workloads nicely fail over and minimal downtime. Patching the infrastructure. HP has a process called HP One Touch that allows you to patch this infrastructure with no downtime or very, very minimal downtime depending on what you're patching. So you'll notice that the infrastructure utilizes the C3000 blade enclosure. This means that we can host 8 blades, each blade with 256 gigabytes of memory. In comparing this to, say, VS2 or VS3, they use the C7000 blade enclosure. This is for a different workload. You'll see that the amount of memory per blade in that configuration goes up to 48 or 64 typically, right? So that's more CPU heavy. But I/O, it doesn't have as much I/O capacity, certainly not anywhere near the bandwidth of the DBC reference architecture that's tested. So let's talk about the software stack, and let's see what's in here. At a low level, we integrate with Insight Control Manager and the Insight Control software to be able to raise alerts from the hardware. You have a storage failure, you have a power failure in one of your power supplies, everything is dual power controlled, we raise alerts. This, of course, also integrates with the Operations Manager, Virtual Machine Manager, so that very, very easily, connecting into this infrastructure, you can move workloads between different parts of the solution very easily. We also tie in with System Center Configuration Manager and Operations Manager to be able to manage those alerts. So now you can manage by exception rather than sitting there looking at logs every day, right? And of course, System Center has plugins to be able to manage and view and capture information from SQL Server to be able to read and distill those logs. All this is protected by System Center Data Protection Manager. You're not forced to use Data Protection Manager. You can install your own backup tools, but Data Protection Manager is built into the solution. So if you want to back up a database, you can do it with DPM. If you want to back up an entire virtual machine, you can do that while it's running with DPM. So this is in detail the software stack. There's even a license for Opalus. HPTS can go through and set this up. If you want to do your own customized workflow, we provide the self-service portal. If you want to do standard workflow to be able to create new virtual machines, all this comes part of the infrastructure. Now, right now, this is built on Windows Server 2008, but of course, you can also upgrade that to Windows Server 2012. And we'll talk about some of those features and what kind of it unlocks. Let's talk now a little bit about the storage connectivity and how the hardware from a storage perspective hangs together. Instead of using fiber channel or SAS, we're using iSCSI in order to make this work. Why? Because it's very fast and cost effective for what you need it for, right? Dual 10 gigabit Ethernet switches. In a half rack configuration, you've got configured effectively, so you get all of the connectivity to the areas with the blue background. Moving to a full rack, essentially we come in and slot in the extra blade infrastructure, make the extra connections, and this is a very, very short process to be able to do this. Minimal downtime. Some of the common usage scenarios. As I mentioned before, when you're starting to do consolidation, this is all about getting your workloads that were on antiquated servers that in the background, in previous years were too hard to upgrade. You can get that onto a platform where you can take snapshots. You can upgrade that in place. You can reduce the risk. The whole idea of consolidation using this platform is risk reduction. Being able to take a unmanaged, say an old, SQL Server 2000, because believe you me, there's still many customers out there that are still running this stuff, or even SQL Server 2005, where people don't have the skills anymore to figure out how to upgrade that, or applications that were very hard or risky to manage and upgrade. You bring that into this environment, you can take a snapshot. You want to do some testing? Fine. Mount that snapshot up as a separate environment, do the upgrade there. Test it. Go through the full UAT process. If it doesn't work for you, fine. You have understood where the problems are. It's not a situation where you now have to build in your own rollback plan in order to be able to have another machine potentially ready to go, a fully physical machine to be able to take the workload. Typically, when customers do upgrades on physical hardware, they buy another physical machine. They install a new operating system, new SQL Server on that, disconnect the old one from the network and transfer the database across overnight. And, cross your fingers, everything goes well. Right? In this environment, you don't have to buy extra hardware to be able to do that. We can also go through, as a matter of fact, and bring in workloads, both obviously from physical machines, but also from competing virtualization platforms, VMware, Citrix, and so on and so forth. You connect to the machine, creates an image, and brings it into the DBC solution. So the hardware components, let's have a look at that. In a full implementation, you would get 8 blades, 2 terabytes of memory that we talked about before, all redundant in the background, in the power supplies and memory and so on and so forth. There's also the redundancy in the virtual connects. If you see these little slots on the back here, let me get my mouse. Okay, here we go. These little slots here, these are for the virtual connect. The virtual connect is effectively a software-based or firmware-based switch. So you can assign different networking bandwidth to each one of those sockets. So we've configured this talking to HP and our partners, and after a lot of testing, appropriately, so that we give you the redundancy and high throughput capacity. So there's 40 gigabit connectivity to your customer's core switch or core switches, and that's also redundant as well. So the hardware components in the storage, you can lose multiple drives. In fact, you can lose up to 25 drives in this configuration with no performance loss, no data loss. You can lose an entire chassis in this configuration with no data loss. So you can lose an entire D2700 with no data loss because everything is mirrored under the covers. The P2000 effectively has got dual mirroring, dual RAID, dual power supplies, dual memory, so everything is redundant within the box. Okay, that's why there's only one of those per storage block. So within a full rack, you have 22 terabytes of usable disk space that's highly available and performant. How have we connected up the network infrastructure? So this is a doubly linked chain, if you like. So you can lose cables and your iSCSI connectivity will remain unaffected. Many times we've gone through and seen how others have configured network infrastructure or iSCSI infrastructure at a storage level. We've done a lot of testing to come up with this kind of configuration here. Everything from the P2000 and the configuration of the P2000 within the machine itself so that it's performant. The LUN layout, to configure that potentially could take you weeks, even with the recipe, because there's a lot of information and IP about how we've done it, why we've done it, and a lot of testing behind this. So the question was, the daisy chaining here was not necessarily for performance, but for essentially fault tolerance and high availability. Absolutely correct. Absolutely correct. Because there's still the 10 gigabit iSCSI connectivity going through that, but you want to make sure that there's multiple paths to those data volumes. Yes, it's definitely for high availability. So we've also got multiple switches. And we work with customers that tell them to turn off parts of these switches or rip out the power cables from these switches to prove the high availability of the actual design to them and to also their architects and IT departments, right? So this is not something that, you can take our word for it. The Virtual Connect and the Flex 10, this is the last picture down the bottom. This is the Virtual Connect module, which is the firmware configurable or software configurable switch, where you can assign different network bandwidths to each one, whether you want it to be an external port, configured with 1 gigabit, 2 gigabit connections, or an internal port with iSCSI, and so on and so forth. Configuration of that is actually quite challenging as well. So we give you all the recipes for that as well. Now, you've heard me say that per rack we're talking about 200 virtual workloads or 200 database systems. I mean, where did I come up with this number? And the first question I usually get from folks is, well, how do you know it's 200? How do you know it's 200 in my environment? Where did this number come from? So there's some math behind this. This is not a number that we kind of plucked out of thin air. So at Microsoft and in other environments, we've talked to customers and we said, okay, what kind of hardware infrastructure do you have? So we've talked to a number of customers. Typically, this could fall into a number of buckets. 3 buckets mainly. So the small, which is 1 processor machines, 2 gigabytes of memory, a small amount of IOs per second, not necessarily being used heavily. Even 50 IOs per second on a 100 gigabyte kind of database is actually quite considerable, right? This is not your database server that just kind of sits there gathering dust. People are actually using this. Right up to the large, which is 400 gigabytes or so in size. These are templates. Think of it as different buckets where you can slot in your workloads, okay? So yes, you're always going to have workloads that exceed this and workloads that are smaller than this, right? So for workloads that are considerably higher than requirements of 16 gigabytes of RAM, we can go up to 64. Or you want to put in databases that are over a terabyte in size, potentially DBC is not for you, right? this is effectively to consolidate and be able to get the cost savings that you need through optimizations. So what we've seen is that the number of servers, if we say 55% of the workloads in this reference architecture is a small, 35% is a medium, 2 virtual processors, and 10% large. That is a good mix. And adding that together kind of equates to around about 200 workloads per rack. Now, these are very conservative figures, as I've said before. When we have done a test to see what's the breaking point, we've pushed an entire rack up to 1,000 workloads. So when I tell you that we can get 200, this is a very, very conservative number. And quite frankly, you might get more than this, okay? So when you, let's have a look now at how we're laying this out on the reference architecture itself. In the diagram above, obviously we needed to make sure that we can fit everything on the screen. So you'll see a big section of the capacity seemingly in the solution on Blade 1 is occupied by System Center. In fact, it's quite the reverse. We've had to make the fonts big enough so people can see it. But normally about 10-15% of Blade 1 is taken up by the System Center componentry. And again, all the System Center componentry is virtualized. So you can move that between the different parts of the appliance. 80% or so of the reference architecture, 80% of the blade is then available for user workload. And you can use tools to get the capacity planning. There's tools, reporting services is built into this, so that you can run pre-canned reports. You can get information about usage, CPU consumption, IO's consumption, and so on and so forth. Active Directory is also made highly available because we've got multiple copies of Active Directory, each one running on its own blade. So in a half rack, you'd have 4 Active Directory instances, all on the same AD, but effectively it means that if you even lost cluster connectivity for whatever reason, that Active Directory would still be able to do the internal validation from a security perspective. Now, your workloads do not run in this Active Directory. Your workloads run in your customer, your Active Directory. This AD is for the management of the RA. Also, obviously on Blade 3 and Blade 4, there's a lot of free space so that you can apply your own workloads. We have the ability to have all of the workloads that you bring into this reference architecture, the solution, marked as highly available. So that means you can do live migrations between the blades. You can do automatic failovers, and we routinely tell customers during testing so that they can validate it to themselves to rip out an entire blade while it's running. From a HA and a DR perspective, as I mentioned before, the HA within the reference architecture is built in. From a DR perspective, in all honesty, we see about maybe 10 to 15% of all of the workloads running on this reference architecture really needs DR. You know, DR to the point where you need to be able to fail over without any loss of data within seconds. So for that, you can benefit from database mirroring, or if your requirements are not that stringent as far as failover time, log shipping, and there's other third-party tools that you can use as well. So one of the things that we typically see and through discussions with customers, and when we ask, so what about disaster recovery? Do you want disaster recovery? Every customer says, yes, absolutely. I definitely want disaster recovery. I want to have 2 different RAs in 2 different data centers, and I want DR across all these different workloads. Fantastic. So what kind of network pipe do you have? Well, we're kind of using a shared pipe, and we have a 256K connection. Okay, and that's where the conversation needs to hit reality. Okay, you're not going to be able to get the data and the bits fast enough from one data center to another to be able to do this. So then, and also the cost as far as the pipe is concerned to transfer all this data, it becomes cost prohibitive. So typically when we start to have some serious conversations as far as the costs, what really needs DR, we typically find out a very, very small number of workloads really needs DR. Because we're talking about, if you're talking about this is your SAP system that's 10 terabytes in size, well, it shouldn't be on DBC anyway if it exceeds a terabyte in size, right? That's one of the limitations. The clustered shared volumes here that we're talking about are maximum size of about a terabyte in size, right? So you don't want to put bigger than that on this. From a HA connectivity to the customer network and the interfaces from there, multiple dual connections. You can lose an entire virtual connect. In fact, rip it out during testing. In front of the customer. All this stuff that I'm telling you now, this is in front of the customer. In fact, we have the customer do it. Connectivity to their main switch so that you can have the connectivity to both switches in their environment, say the Cisco 6000s or whatever it is. From an internal network topology, here's the design and the implementation, how that works. At a base level, the lower level, we have the Flex 10 NICs, which are, again, firmware-based NICs. They internally connect to the teamed network interfaces within the virtual connect. So we provide a team production and a team backup. So in order to be able to do backups, there's a dedicated network for that. The team production goes over 2 different network cards internally, even though to the VMs they appear effectively as one network. There's 2 virtual switches, each one connecting to 2 NICs on the virtual machines. So you'll see in the System Center componentry, there's a backup network and there's a production network. So you connect to both of these. And each one of these networks has got dual paths for redundancy. From a performance testing capacity and perspective, we say that the reference architecture can support over, in fact, 60,000 random IOPS per full rack. And that is at a 60-40 read-write kind of ratio. Fully random I/O, no sequential I/O, 100% random. And in fact, you can do that. You can test it yourself. Download the iometer from Intel or off the web or even SQL I/O and test it yourself to be able to prove the IOPS that you're going to be able to get. For this kind of price tag, there's no other solution out there that can quote you for this kind of money, these kinds of densities of workloads to be able to support that with this kind of high availability straight out of the box, to be able to deploy this in such a short period of time. The storage block capacity. So in a full rack, which is the 4 storage blocks, we provide nearly 400 disks, 20 spares, and this is hot spares, so if you lose a disk, it automatically another disk falls in its place. An alert comes up, the man from HP can come over and replace that faulty disk, and off you go. This is with no downtime as far as you're concerned. This is the virtual connect design under the covers and how we've segmented this. Multiple gigabit connections. We quarantine a gigabit for management, and the rest of the 10 gigabits goes to iSCSI connectivity. And we have a total connection to the customer's core switches of 40 gigabits. That's 4 channels of 10 gigabits each. So lots and lots of connectivity as far as users being able to get to this reference architecture and be able to pummel it with with data in and out. So there's no bottlenecks there. From a disk storage block and how we've carved up the LUNs and the clustered shared volumes, effectively you will see, if I can get my mouse back, you'll see effectively that the disks are mirrored. This disk is mirrored with this drive is mirrored with this drive, and the same thing follows right across the whole disk pack. And therefore, it is easy to see how you can lose an entire JBOD or D2700 without having any data loss or any performance loss, for that matter. In fact, we used to have some YouTube videos where we rip out hard drives and display the performance on Performance Monitor to see if there's any loss in transactions or anything like that. So in a half-rack solution, there's 10 clustered shared volumes, each roughly with just over a terabyte in size. As a recommendation, we say that you'd want to keep your workloads going on to this reference architecture at around the 400 gigabytes max, because you don't want to have your VMs being too chunky. Simply because you don't want to have, you want to be able to have lots of different types of workloads, being able to move these workloads with ease. You don't want one, how shall I say, workload to fill up an entire clustered shared volume. It's not an ideal. You can definitely do it. It's not ideal. It's something that you would want to have, be able to mix and match the workloads as you scale out. So originally, it would have been great if I was able to bring a DBC here with me so you can see it, but these things weigh about a ton and are really hard to get through customs. So instead, I've got some nice screenshots because I wanted to show you under the covers what it looks like from a clustered shared volumes perspective and some of the workloads. So you'll see that we have a number of CSVs. These are normal cluster resources. So all of the blades are set up in a cluster, and the workloads themselves are services on that cluster that can fail across from blade to blade. The services are here, and you can bring services online and offline. Of course, you wouldn't necessarily have to use this tool to do that. The System Center Virtual Machine Manager tool is a great way of being able to move, doing live migrations, shut things down, bring new things up, deploy new infrastructure, and being able to leverage tools like the self-service portal. From a networking configuration in the software in the cluster, you can see that we have multiple dual networks for the cluster networks with the heartbeats, and dual networks for the iSCSI configurations, iSCSI traffic, iSCSI A and iSCSI B. We also have separate networks, so you're not jeopardizing any of the I/O, the internal I/O of the solution when you're bringing across new infrastructure using either live migration or doing an import of a virtual machine. So you can have your virtual machines and your infrastructure running at full capacity and still bring in more infrastructure. So if you liked all this based on Windows Server 2008 R2, and we use the Data Center Edition, you're going to love it with Windows 2012 with the new Hyper-V features, right? And it's true with systems with Windows Server 2008 R2. There were some limitations. You know, you could go up to 4 virtual CPUs. With 2012, all of these limitations effectively go away. We're talking about 64 CPUs per virtual machine, a terabyte of memory per virtual machine. Now you can start putting on much higher workloads. Again, for the sweet spot of the types of things that you're looking at consolidating and virtualizing and bringing into this, you're not necessarily going to need all of this, but the capacity is there for you to grow. Because in the future, our machines are only going to get bigger. Extra features, and this again is a white paper down at the end of this slide. So you can go through and have a look at it. It talks about all the different features, new features with Hyper-V. Some of the new, other new things is being able to bring about the NUMA topology. If you've set up large, really fast SQL servers, you'll notice that you actually have to configure NUMA, which stands for non-uniform memory access, so that you can get the best performance out of the CPUs and out of the memory that you have. And this is a really in-depth topic. Happy to talk about it probably offline at the end of this presentation. Also, dynamic memory with memory reclaim. In 2008, we could allocate memory dynamically, but we couldn't bring it back. We couldn't take it away. In 2012, you can take that memory back and redeploy that memory on another VM. Plus many, many more features that, I'd have to shrink this down to 8-point font to get them all in there maybe. So have a look at this white paper. There's a lot of info. Now, this brings me to a very important topic, the map toolkit. The map toolkit is your Swiss Army knife for being able to do consolidation projects easily. If you've ever done a consolidation project with more than about 2 or 3 servers, you'll see how difficult it is to try and get all the information that's out there on hundreds of different servers all across a complex environment. Outsourcers and companies typically spend many weeks or months gathering just this information, shoving it into a spreadsheet just to get an idea of kind of what you're looking at. How many CPUs? Simple things, right? We're not asking for complicated things. What version of SQL Server? What version of the operating system? How much memory? How much disk? And various other, version type information. Just getting this information can take months in a large environment. Well, the map toolkit can go through and you can deploy that within your environment, and it will go through and give you all of this information. Produce reports. There's a number of pre-built reports that come with Map Toolkit. Map Toolkit is a free download. So go on the web, type in Map Toolkit version 7, or even just Map Toolkit, download version 7, and have a play with it. You'll get an idea of what I'm talking about. Now, once it does an inventory, you can go back and say, now, for all the servers that you have found, go back, reconnect up to those servers, and you type in the credentials and various things like that. And now tell me, over a period of time, the average CPU utilization, the IOPS, the size of the databases, what am I running? The number of processes that are running over time. So just, now you've taken it to a new level. Getting this information, okay, someone's playing music. Getting all this information, we're talking about a serious effort here. And the Map Toolkit will be able to do this. With the Map Toolkit, there are extra tabs in the user interface that expose some extra reports. We'll be able to do sizing and tell you how many hosts, and therefore you can determine from that if you need a half rack or a full rack or multiple racks in order to consolidate X numbers of virtual server type workloads. So it'll tell you, for example, if the amount of memory that you have in your server exceeds the capacity that is in the largest template, because we bucketize everything into these templates that we're talking about, the small, the medium, and the large, right? Then there is a small amount of human intervention. You always have to have the human intervention, that you review all the output reports and you say, okay, was it really greater than this many gigabytes of memory or this many hundreds of gigabytes of disk space? And then you can calibrate that and, the fine-tuning and the polish. Reference architecture also allows you to have the provisioning using the self-service portal to provision new SQL servers on demand. You create your templates. There's some templates already built in. So you want to provision an extra 5 servers? That's fine. You have authorized people that can follow the process. There's a defined workflow with approvals already built in. You can assign different roles and different permissions to those folks, and then they can roll out new infrastructure really, really simply. Usage metering and chargeback. These are built-in reports and user interface bits that will be able to show you on a per month basis, per week basis, by department, by resource group, what resources are being used. CPU, memory, you can assign different costs for a memory, cost per gigabyte of disk space, cost per CPU. And therefore you can get really nice reports and graphs by which you can go to different departments should you wish to explore chargeback and metering. So I also want to touch base on some of the support aspects. So this is very simple. All you need in order to be able to support this from Microsoft is Premier Support. From HP, you can choose anywhere between 4 different offerings. And this is largely, the amount of time that you're willing to wait for spares to appear. If you lose a number of drives, or if you lose a cabinet or something like that, if they have to go back to the factory and bring it in, that could obviously take some time. In the critical service and critical advantage offerings, obviously they cost more. HP can certainly offer to have a locked cabinet with spares so that they can very quickly switch out parts with minimal fuss. This used to, the DBCRA used to previously been released as an appliance. And for that, you needed Premier Mission Critical Support. Significantly more expensive, but it also gave you the ability to have far faster response times. With the reference architecture, you no longer have to purchase Premier Mission Critical as far as support is concerned. That gives you extra flexibility. You can support that using normal Premier support. At this stage, there's a number of resources on the web already. I urge you to check out the links as far as what's provided in this session. Happy to take further questions. Please go through on the website, fill in the evals, apply for some of these presents and things, and you might be able to win things. Based on that, I've got some nice little goodies here for you. So these are light, so I can basically throw them out. So go ahead, ask a question.